In part D, it is asking explain why g inverse of x cannot be found. Now, as g of x was x squared plus 4 and the domain which was x was an element of real number. So if you have a quadratic curve, for it to have an inverse, it must be a one-to-one function. But as x is taking all the values of real numbers, so it means the function will not be one-to-one. So we'll write that as g of x is not one-to-one, that's why it cannot have an inverse. So we'll write as g of x is not one-to-one function. Now in part E, it says that show that 1 plus 2 upon 2x minus 1 can be expressed as 2x plus 1 upon 2x minus 1. So first we'll take the LCM, which will be 2x minus 1. 1 will multiply by 2x minus 1 plus 2. So minus 1 plus 2 will become a plus 1. So that will be 2x plus 1 upon 2x minus 1. Now in the second part, it says, hence find the area of the triangle enclosed by the tangent to the curve y equals to f of x at the point where x equals to 1 and the x and y axis. Now to understand this, we'll try and make a graph over here. So let's say if this is the graph and the tangent to the curve at the point, and this point is x equals to 1. So if I make a tangent over here like this at x equals to 1, to find the area enclosed, we'll have to first find the equation of the tangent, find the points at which it crosses the x and the y axis, and then use half base into height to find the area. So first, to find the equation of the tangent, we'll first find the gradient of the curve, which is the dy dx. So finding the dy dx, we can now use the form 1 plus 2x minus 1. We can use y equals to 1 plus 2 upon 2x minus 1. So using that, this will become, so derivative of 1 will become a 0. And to differentiate 2 upon 2x minus 1, we'll bring 2x minus 1 in the numerator as power minus 1. So minus 1 times 2 will become a minus 2 into 2x minus 1 to the power minus 2. Will decrease the power by 1 and multiplied by the derivative of 2x minus 1, which is 2. So the dy dx will be minus 4 minus 2 times 2, and then we can bring 2x minus 1 minus 2 in the denominator to make it a whole squared. Now we have the dy dx. Using x equals to 1, we'll be able to find the gradient. So the gradient will be minus 4 upon 2 into 1 minus 1. So that will be minus 4 upon 1, which is minus 4. Now we have the gradient. We need a point on the line. We already have x equals to 1. And now we need the value of y. So to find the value of y, we'll use the expression for y, which was y equals to 1 plus 2x minus 1. So y was equals to 1 plus 2 upon 2x minus 1. Substituting x equals to 1, we will get y equals to 1 plus 2 upon 2 minus 1. So this will be 1 plus 2 upon 1. So y will be equals to 3. So once we have the value of y, x and y and the gradient, we can now make the equation, which will be y minus. So we'll use the formula y minus y1 is equals to m into x minus x1. y1 is 3, so this equation will become y minus 3 is equals to minus 4 into x minus 1. Now to find the points at which it crosses the x and the y axis, so for the x axis, we'll use y equals to 0, and for the y axis, where the tangent crosses the y axis, we'll take x equals to 0. So substituting y equals to 0 into the equation, we'll get minus 3 is equals to minus 4x plus 4. Taking 4 on the other side, this will become minus 3 minus 4 equals to minus 4x. So minus 7 will be equals to minus 4x, and x will be equals to 7 upon 4. So this coordinate will become 7 upon 4 comma 0. To find the y value, we'll substitute x equals to 0. So this will become y minus 3 is equals to minus 4 into 0 minus 1. Y minus 3 will be equals to minus 4 into minus 1, which is a plus 4. And then y will be equals to 4 plus 3, which is equals to 7. So we have the y coordinate as 0 comma 7. Now we know that this point is 7 upon 4, the x value, and the y value is 7. So we can use that as the height. So the area will become half. So area will be equals to half into 7 upon 4. Simplifying this, the area will be 49 upon 8.